Part 1 of Chapter 21, the hematological issues. This, along with the endocrine system, are my favorite chapters of the textbook, are my favorite systems. And one important thing to remember about the hematological system, your red blood cells, is the fact that all of our tissues and organs require oxygen and nutrients to survive. These essential needs are provided by the blood that flows through miles of vessels throughout the human body. The red blood cells provide oxygen, and the fluid components of the blood carries the nutrients. The blood also cleans waste from the tissues and transports cells and other ingredients that are necessary for protecting the entire body from injury and infection. So therefore, very important system that we're going to talk about. Just as a side note, if any of this material is foreign to you in terms of the basic material, I would encourage you to go back and read through Chapter 20. It's actually a relatively short chapter, easy to read, in my opinion, but it has a lot of good information, overview information, and some good figures to review. So, the first disease that we're going to talk about is anemia. And anemia is the reduction in the total number of erythrocytes in the circulating blood, or an issue with the quality or quantity of the hemoglobin that is found within erythrocytes. So if you remember, the function of erythrocytes is to transport gas to and from the tissue cells and the lungs. And within the normal adult, you typically have 4.2 to 6.2 million cells per microliter of blood, which is quite a bit. Your hematocrit is 42 to 48%, and then your hemoglobin levels should be around 12 to 16.5 grams per deciliter. So, in terms of having a reduction in the total number of erythrocytes, what you can have, or how that happens, could be through impaired erythrocyte production. And what you have here is a diagram of that process, where you have the different phases of erythrocyte development. Here you have the uncommitted stem cell. Add erythropoietin to that. Erythropoietin is secreted from the kidneys in response to a variety of things, including hypoxia, that signals this stem cell to become a committed proerythroblast that moves into the phase of being a normoblast, into a reticulocyte, and then finally a mature erythrocyte. So, impaired erythrocyte production. You can have acute or chronic blood loss. Typically, if it's going to be acute, it's going to come on suddenly, and it would actually be a high amount of blood loss. Chronic blood loss, it could be very small amounts over a very long period of time, and therefore that culminates into a loss of red blood cells. And then your body can have increased erythrocyte destruction, or a combination of any of those. So this is a very simple diagram of this process of developing red blood cells. You can look in your textbook at figure 2011. This is a better figure in showing a more in-depth role of erythropoietin on the process of erythropoiesis. Alright, so with anemia you have physiological manifestations, reduced oxygen carrying capacity. That is, reduced oxygen carrying capacity to the entire body. So this could be, again, due to decreased red blood cell numbers, or the decrease in the hemoglobin content or quality within the red blood cell itself. Alright, variable symptoms based on severity and the ability for the body to compensate. So these will depend on how quickly the state of anemia develops. And is there a very small bleed in the large intestine? Does a person suffer from bleeding ulcers and therefore could actually be losing a fair amount of blood constantly? One means of this is a female having heavy menstrual cycles close together, and so then her body simply cannot keep up with the blood loss. So there's a lot of different factors that play into this, but classic anemia symptoms are going to be fatigue, weakness, dyspnea, and pallor. Now, the etiological classification of anemia. All right, how do you classify anemia? It's going to be an issue of inadequate production of red blood cells. Is that why anemia is developing, or is it because of excessive blood loss? So this is an important slide to actually memorize. All right, anemia can be classified as an inadequate production of red blood cells. All right, so why would there be an inadequate production of red blood cells? All right, you can have an insufficiency of materials. So your body wants to, has the ability to make red blood cells, but it doesn't have the components, the building blocks to do that. Or is there an inability to deliver red blood cells into the circulation or into circulation? So they're being made, but they can't get out of the bone marrow. Excessive loss of red blood cells. Right? Is it an issue of bleeding, acute or chronic, or is it an issue of destruction of the red blood cells? So, if you were to have a question on what are the two major mechanisms of how and why anemia develops, and two explanations for each of them, here are your four answers. All right, inadequate production, insufficiency of materials, inability to deliver red blood cells into circulation, excessive loss of red blood cells, bleeding, and destruction. This could potentially be up to 6 points on your next exam. All right, this is just a diagram that talks about or gives a picture to the previous slide. All right, so inadequate production, you're looking at the factory here, the bone marrow. Insufficient raw materials, which could be different proteins, vitamin B12, folic acid, and iron. Or is the factory damaged, and therefore either the red blood cells are not being made or they can't get out of the bone marrow to move into circulation. And then here, excessive loss, all right, external loss, that chronic blood loss or acute blood loss, and then hemolysis, a destruction of red blood cells. All right, now you have the morphologic classification of anemia. And here you have a couple of different things. You have cytic, which is going to refer to size, and then you have chromic, which is going to refer to the hemoglobin content. So there are several ways to classify anemia based on the physical traits of red blood cells. Size is important because it can affect how the red blood cells move through the vasculature, or maybe not be able to move, for that matter. The hemoglobin molecules are going to be responsible for binding to oxygen molecules and then transporting the oxygen to the rest of the body. One could argue which one would be worse, and you could argue both sides, especially if you were at the extreme. In this case, you will not need to know which classification a different type of anemia is. So, for example, you don't need to know that iron deficiency anemia, so we'll talk about that, is an example of a microcytic hypochromic anemia, which means the red blood cells are smaller than normal, as well as they have decreased hemoglobin content. But rather, if a question were to arise, what does a macrocytic normochromic red blood cell look like? All right, well, it would be bigger than normal, but it would have normal hemoglobin content. All Alright, this is a pretty cool figure. Everything's cool. Figure 21-1. Alright, a lot of material, a lot of stuff going on in this figure. But what you see up top is the etiological events that are going to cause anemia to develop. Alright, so decreased erythropoiesis, right, decreased red blood cell production, you have blood loss, you have decreased destruction, and so then when you get out into the body, you have decreased red blood cells, decreased hemoglobin, and then the body has that anemic condition. What does that mean? Decreased oxygen carrying capacity, which means your tissues are going to develop hypoxemia, low amounts of oxygen in the blood, leading to tissue hypoxia. And so then you have the physical manifestations. Very extreme, you can have ischemia, and now that develops claudication. Claudication is pain caused by too little blood flow, often during exercise. Sometimes called intermittent claudication. This condition generally affects the blood vessels in the legs, but it can also affect the arms. At first, you may not notice the pain, or you may only notice the pain when exercising, but it can get worse. And most often, claudication is a symptom of peripheral artery disease, a potentially serious but treatable circulation problem in which the blood vessels that supply blood flow to your legs are narrowed. Alright, then there's weakness, increased fatigue. Alright, so fatigue is going to be one of those main signs and symptoms of anemia. Then you have pallor, decreased color in the skin, the mucous membranes, and with the respiratory system, you're actually going to have an increased respiratory rate and depth, right, to try to pull as much oxygen into the body, right, but unfortunately that's not the issue. It's not a respiratory issue. It's a blood issue. All right, with the liver, you can have fatty changes, increased fatty content within the liver, and that can also occur in the heart and the kidney. And then because of the lack of oxygen to the brain, you can have dizziness, fainting, and then lethargy. All right, so to compensate for reduced oxygen within the blood, all right, now it's going to go to the heart to compensate. The cardiovascular system is going to increase heart rate. There's going to be capillary dilation. There's going to be increased stroke volume, and that is going to lead to hyperdynamic circulation. It can lead to cardiac murmurs, heart murmurs, and unfortunately then high output cardiac failure, which we will talk about in the cardiovascular system. All right, the renal system is going to get involved. It's going to allow for increase of the renin-aldosterone response, increased salt and water retention to try to bump up the blood volume, increased extracellular fluid as well. As the increased extracellular fluid load increases, that moves over here to this hyperdynamic circulation. With the cardiovascular system, increased oxygen demands for work of heart. So you have increased erythropoietin, stimulates the bone marrow. With this increased oxygen demand for work of the heart itself, you can end up having or experiencing angina at the heart. All right, so spend a fair amount of time on this, all right, just looking through it. What's going on up here? Lack of oxygen gives you or results in tissue hypoxia. And so what does that do? All right, then you have the compensatory mechanisms. The heart and the kidney are going to be major components here. So this is part 1.